It's clear that we're going to be talking about healthcare, right? Partially right. We're going to be talking about healthcare, defense, safety, security, and we're going to wrap it all around with this new thing called generative AI. And we're going to talk about what is the single biggest change since the internet. I believe it's bigger than the internet, and I'm going to present to you why we think that and what we're going to do about it. And we need to understand it and do something because it is happening. And it's either you or your competitors or your adversaries who are going to do something very innovative with it, and you don't want to be left behind. If you're in defense, you can't be left behind. So let's talk about what exists today. Generative AI is incredible. How many people have used it in one form or another? Okay, of course, just about everybody. There are hundreds of people who have used this. This technology has taken hold of other technology before it. Now, we all know that. We've all heard that, right? Okay, so there's a new technology. We got to learn it. We got to do something with it. However, what we're going to do with it over time is have software drive it. Now, the reason we had Tony Stark and Jarvis is because there was a true interaction between the software systems and Tony Stark. Who is making the decisions? Both. Who is overriding the decisions? Both. Even the system told Tony, don't do that at some point. So it's an interaction between humans and the system. But it doesn't actually have to even be with humans in the loop. And I'm going to give some examples of that. So, software applications are the next set of drivers to prompt generative AI. Now, how many people have heard of what I just said being promoted anywhere? Okay, I see a few hands. Was it besides me? Anyway, point is, very few. I spoke to a couple of Gartner analysts on generative AI, and I said, is anyone looking at moving real-time data automatically into generative AI? And the answer was no. And I asked another analyst, and the answer was no. But the interesting thing, this was only about 2 months ago, one of the analysts I asked had to really think about it. Now, I thought about that. They'd have never even considered that before. Now, maybe we're wrong. Maybe it's not going to be automated, but we're not wrong. It is absolutely going to be automated because either you're going to do it or your competitor is going to do it or your adversary is going to do it. And you cannot be left behind. That would be the innovator's dilemma in spades. So let's talk about what types of applications might exist. And these are just some high-level examples, and these are real. So in this case, this is Las Vegas, and imagine if a city can talk. So if the city can talk, we can see our camera just detected a crash at some location, and the system automatically promoted or collaborated with a human who said, what is the severity? Are there any injuries? And then the system says, no serious injuries are observed. Okay, so the system is generating this interaction, this collaboration, right? However, look what else the system did. I have dispatched the closest officer. System took automation. Now, automation based on generative AI interface. Now, that's not bad. Sending out first responders, you could make a mistake, not the worst thing in the world, right? Sending off a missile, a little more challenging. And we'll talk about what can be automated and what some of the issues are when you automate. But again, I want to reiterate something. This technology is here. It is absolutely here to be used. And this is Advantic. This is what we have been doing for all of engineering for, I'd like to say 5 years, but it's only been around a year, so I'll say for a year. We had the infrastructure to do it, and we tied our infrastructure to generative AI. And like I like to say to all of our employees, this generative AI makes our collaboration capabilities fly like never before. To some degree, we're lucky that it came about. I'll take luck anytime. But we had built the most robust system for building real-time applications that exists. So we're the ones who are in the forefront because we had the technology to do the integration. And we saw that these are the kinds of systems that can be built. Let's look at another one. This one is a situation in Japan. very large system integrator, customer of ours. They are building automated systems that detect when there are problems, disaster management, and automatically get first responders to the right place at the right time with the right information. They get it from satellite images, sensors out in the field, social media, and the like. But what their next step is to automate it. So here, hi Sam, severe flood has occurred in your area, and I'll have to read it because I don't know if everybody could see it. And you'll need to evacuate. Can we give you an evacuation route? And of course, okay, thanks. There's the evacuation route with a couple of choices. Now that's not so far-fetched that that would be needed, right? Does that exist anywhere? Of course. There's no human involved here. There's no human involved here. The system gave Sam kind of like an Amber Alert, saying you're in a treacherous area. And Sam had already, had connections to the system, and then the system automated the advice to Sam. Then he goes on, okay, thanks, let me just pack a bag. Is my mother safe in her home? Well, this system obviously has lots of information, lots of data from different sources, and that's one of the things I want to focus on too, is the systems that are going to be built today are not replacing existing systems. That's absurd. What they're going to do is integrate existing systems, take the data from existing systems in other places and make it active. By using generative AI, they can take that information and see what activities, what should be done. Gaining situational awareness is really the key here. And the situational awareness ain't going to be by all new sensors. There's a lot of information we already have out there. You need to combine it together. Then the system responds. Based on that address and current models, I'm happy to say your mother is not going to be impacted by the flood. So this type of system can be built today. It'll be evolved over time, but this is the kind of possibilities that we're looking at. Here's another one. Hospital situation. The system noticed that the ventilator settings were showing some problems. And it could be a combination of ventilator settings, real-time feeds, and environmental feeds as well. In a hospital, if it is in a hospital, vital signs are being read continuously, so you have that data. And so you can get the data from the ventilator, and you'd even get the historic information about the patient and combine all that together. No human interaction. And then the system looks at that whole situation and offers that information to the healthcare provider, who then responds, what are the patient's latest vitals and current ventilator settings? And I won't even attempt to read the answer there. But anyway, it gives an answer that is appropriate for a healthcare provider. Now, could there be automation here too? Possibly, and I'll talk later about when you want to automate and take actual action. But the automation that does exist here already is that all that information is continuously fed into a generative AI system. When I say continuously, maybe it checks every 5 minutes, every half hour, and makes decisions using generative AI on what information should go where, to which healthcare providers. That's the first step, and that's relatively easy. This is the kind of technology that we're going to be seeing. Now, you can apply it, everybody here in your own industry, and I would be willing to bet that you could think of loads of use cases where you or your customers can actually utilize these types of systems. And that goes back to my comment that this is the next generation of technology. And it is going to be bigger than the internet itself. It's going to be managing the world with information with or without people involved. And we know the world needs it, whether it be disasters or defense. There are a lot of situations that we have to deal with today that are problematic. And then what about safety and security? We are lucky to be involved in many of these situations, and we're seeing it. And the interest level we're getting and building these types of applications is absolutely incredible. In my career in the industry, and I've been in 5 software companies, I've never seen as much demand for what we're talking about and what we're doing. Basically automating generative AI. Now, if you talk to the market and see what's going on, very little about automation today. There were a few hands went up. Very little, surprisingly little. Wouldn't that naturally be the next step? Right now, humans are busy doing it. All right, but what you need under the covers to be able to do it is a system that could sense, analyze, and act. But sense, not just sense from sensors, as I mentioned already, acquiring information, services, what's the weather, knowing that, what's the satellite images show, what are the problems we're dealing with, and then integrating loads of existing systems that have different information and putting it all together. These are challenges alone. Then analyze and recommend. Analyze using standard, what I call narrow AI, based, and by the way, generative AI and narrow AI have much less in common than you think. Yes, neural networks built these systems. That's true, and they have that in common. But what narrow AI does, you want to know if a machine is going to fail or not, you have a data set of information that when this parameter goes this way, voltage goes too high, probability of failure is this and that, a fixed data set. And the same thing is true with video imaging and so on. Fixed and small amounts of data. Generative AI, on the other hand, has all of mankind's knowledge pretty much available. And it's not just knowledge, specific facts, but it's cultural information too. And it's also concepts on what should be done. Language is very robust and very deep. And that representation of our language, of different languages, is put into these what are called large language models, which are just these data sets that represent all of the words possible as read on the internet or private data. And I would argue that that information is just not raw, it's not limited to raw data. Because if you look at poems, if you look at essays, they're all talking about concepts, ideas. Well, those concepts and ideas are all put into these LLMs. And not only that, but these concepts and ideas come from multiple systems so that these generative AI systems can integrate the multiple systems and come up with new ideas. Some risk with that, right? I think we've all heard of hallucinations. They don't always come up with the right ideas. That's a problem. But they definitely come up with ideas. It is very different than the standard or more narrow AI. It is a whole new set of technology. In addition, it is not deterministic. It changes when you ask it even the same question over and over again. Okay, more on that in a minute. So you want to analyze recommendations at minimum and potentially orchestrate responses. Now, how do these real-time systems, how are they built and what's required? Well, there are a couple of very simple, or not simple, but a few requirements. First of all, where does the applications I'm talking about run? Cloud? On the edge? They run everywhere. They run where appropriate. If you need to be responsive, it's going to be on the edge. If you're reading images, it's going to be on the edge. In addition to that, these systems have to communicate among themselves, these components here, and they must be super reliable, especially if you're dealing in military situations, healthcare situations. Messages that are sent have to be guaranteed to get there. This is a whole new level of technology for real-time systems that's required. And there are a lot of products out there that talk about low code and you build, nice web interfaces, this and that. And if they crash, so what? For most part. You might not enter your order, that's frustrating. But if you're actually giving a command to a drone in a military situation, that system must guarantee that that drone gets the right command, especially if it's telling the drone to stop, desist from what it's about to do. So these systems have to be super reliable, as I mentioned, integrate information, and they must be changeable. If you want to fix a bug, you got to fix it everywhere. So we have these very complex distributed systems. Now here's an example of orchestrating a very complex system. This is a real-life system that we're doing in the Middle East. First thing that happens is a problem's detected. One person attacks another, as an example, or a gunshot goes off. So you want to get guidance right away to where the problem occurs. Next set of actions is you want to inform the first responders. You want to send the information to the 911 or equivalent and send the security guards the information. But you're not going to stop there. These are synchronous activities, meaning you do one, you do the next, you do the next. You also have the capability of using more extensive AI and analyzing what happened. Was it one person, 5 people? Were they running first? How bad is this situation, and did it evolve over the last 3 seconds or last minute? That's asynchronously done. You want to see if you could recognize who the perpetrators are. Are they terrorists? Are they known terrorists? What kind of background do they have? What are they likely to do? And then you want to use Gen AI to make recommendations. How do you approach the situation? Which entrance should the first responders go through? The front entrance? Is there a sniper up on top? Do you want to send them to the backyard or whatever? And you also want to learn from what's happening in real time. So if you sent some first responders to the front entrance and they were shot, you probably want to go and get into that particular situation through other entry points. And you could do that by training what's called a vector database, basically adding the knowledge in real time of what's happening. Now, this is pretty sophisticated, right? This is actually what is being built. And not all of this, but over time, this is being built. And so the argument is, if you don't build these kind of systems, your competitors, your adversaries are going to. And guess what? They care less about often they care less about the accuracy, especially if it's adversaries. Okay, so what kind of requirements exist to build these kind of applications? First of all, it has to be super agile. You got to create abstractions to hide the details, because we use loads of different products under the covers, and you don't see them. You're going to see a demo later, and it's very easily built at a high level. You need to use multiple LLMs, maybe for different reasons. Update prompts when things change. You're monitoring a real-life situation. Something could change immediately. You're telling someone to get out of the flood, go across that bridge. That bridge collapses. You want to get that information immediately into the vector database, the database that would be guiding future people, and then update the guidance you've already given to people to go over that bridge. You want to include proprietary data. I'm going to go quickly for time purposes. Collaboration with humans, absolutely a must. The situation that's being built using Vantic in Japan, they get, if you're in a flood, and say you're in a subway, you'll get like an Amber Alert on your phone, and it says, do you want help? Now, this is being built right now by our partner there. It'll take them a little while, a year or so. But the system will say, you say yes. Then it's going to say, okay, we see where you are. Walk to the end of the subway station, walk up that stairway, cross the street, and go across the bridge. And this type of information requires sensors, location, knows where you are, your phone, GPS coordinates or equivalent, and will give you guidance and has to keep track of where you are. This is a complexity that's pretty profound, but they're building it. They're building it right now. Learning in real time, I already mentioned, bridge goes down, you want to stop telling people to go across it. You want to be able to adjust the system. What if there's a defect in it? Then you want to be able to trust the system. Now, how do you trust generative AI? How many people here have heard about hallucinations? All right, that's pretty much everybody. Well, these systems are hard to trust, but there are at least 2 ways, and we have patents pending on these approaches, that you can do things to verify that it's accurate. One is you could ask, where's the reference it came from? So in a medical situation, it might be a particular manual, Harrison's manual. You want to, well, where'd that information come from? What chapter was it say? So that the healthcare provider can ensure that before he takes action, he's getting valid information, he or she. Another way to do it, and this we also have a patent on, is voting algorithm. Now, this came from Paul Butterworth when he worked at Hughes Aircraft, working for the military indirectly. And what you can do is get 2 or 3 systems. They could all be LLMs, but they don't have to be. It could be standard AI, it could be just logic that you've coded. If they all agree to send off that drone, only then do you automate the drone being sent off. So it's kind of simplistic in concept, but boy, that could save some very difficult situations from occurring. In addition, even if you do that, you want to get the human involved and tell the human asynchronously, here's the action I took, so that the human can change it. Next thing, and the last thing I want to mention here, how about testing these systems? We're dealing with, most of us are involved one way or another with software. Software systems are deterministic. You set up the requirements, the programmers develop the system, and they have fixed outcomes. With generative AI, the outcomes can be variable because you're getting the generative AI system or systems to give you recommendations. So how do you test a system like that? Well, you at least test before the prompt, because that should be fixed. But testing becomes a challenge. I don't know if Paul's going to touch upon this. We are working on that, on addressing that issue too, so that you can test things much more effectively, given that generative AI changes. Okay, I have pretty much out of time, so I'm going to go very quickly with the last couple of slides. This trend of generative AI is being funded like crazy. This is from the VC community. And the amount of funding from VCs has actually dropped from 22 to 23, 47 billion to 42 million. The amount of funding Gen AI has gone up skyrocketed. So what does that tell us? That tells us that there are loads of startups and opportunities that are being addressed out there. And so therefore the argument is we all need to move on it. So what actions can you take? First of all, don't wait. As I said, competitors or adversaries, they're not going to wait. And you don't want to have the innovator's dilemma. You want to be able to address this technology before your competition does. Using an agile creation environment is an absolute must, because we are dealing with complexity at unheard of levels. And so therefore, you need, well, we do this clearly. We're not going to be the only ones over time, but right now we have a lead. But creating an environment where you can hide the complexities is a requirement, because this is not simple programming anymore, not even close. And what they call low code or no code, the current technologies there are not going to do it. So you got to be able to create things super fast. And what should you create? Well, first of all, automatically prompting for recommendations. That's an easy one. You can present it to the healthcare provider. Reducing hallucinations, as I mentioned, you got to pay attention to that, especially if you're going to take action. And so automate, but carefully. Okay, so what we're looking at is a major shift in the world in how technology is going to be used to operate the world. And I'm talking everything from healthcare, remote patient monitoring, to defense situations like we've never seen before, where levels of automation and integration of different systems have to occur. And either we do it or our adversaries are going to do it. The knowledge that exists for all of these systems, it's all of mankind's knowledge, with opinions. When generative AI, when LLMs are created, they're reading loads of opinions. Maybe there's agreement among these different opinions, maybe not. These real-time systems are going to use generative AI, and it will be more impactful than the internet, because we are about to use technology to manage the world. And software systems are going to, I've been in this industry forever, 5 companies. We're going to create software different. It's going to do things differently than ever before, because it's going to have kind of like a subconscious or a history and knowledge database to base decisions on, that you don't even know exactly what those decisions are going to be. So it's a whole new world of computing, but it's going to happen. What we're seeing, safety, defense, healthcare are going to benefit big, and they're the first adopters. And agility is a must, or failures are going to be predominate. So, ready, set, go, guys. This is happening. And not only am I serious about this, but it gives me a little bit of fear, because we're going to start changing how technology is used so quickly, and we're going to change the way the world operates. And the world needs it, okay, but this amount of change is going to be a challenge to all of us. And what we're looking at as a company is providing the infrastructure and the robustness to enable it to be successful. And we focus on that. And it's not going to be 100% perfect, but at least we've got to focus on it. And you using these technologies, same thing. Got to be careful with it, for sure. Okay. There is a number of examples out here. I just want to say one more point. The growth curve we're about to go through because of generative AI adding to cloud, edge, AI, and IoT, it's exponential. Our ability to build on these technologies is limited today, and new technology infrastructure is absolutely required. Okay, thank you.
Marty, before you step down, any questions that were generated on this? Thoughts, comments? Yes, sir.
John Weiler, I run a little think tank called the ITAC, and we've been on the initial assessment. We find 1,000 points of light structured with many different kinds of data labeled incorrectly. And now they want us at CDAO to figure out how do we apply AI to this problem of there is no original architecture, there's no common data model, and we don't even know what the authoritative data sources are. Thoughts?
Well, first of all, there are two problems there. One problem is the physical. Two problems at least. Okay, two I could think of. One is the ability to integrate the data itself. You're approaching different systems located in different places. You've got to do something. I would argue that in many cases, standard AI should be able to do that for you, but I'm no expert in that area, so I don't know. I do know that getting, depending on data can be risky. So one problem is being addressed by technology like ours. The other problem is a lot of programming, a lot of AI, and a lot of figuring it out. And the only comment I'll make on that additionally is you've got to be able to change that AI immediately as you discover new problems, modify it, et cetera. But there's no alternative to that.
So Marty, any other questions real quick? Yes, ma'am. Please say who you are and why you're here and the name of your favorite cat.
Yeah.
You already know that. Okay. Hi, I'm Nadine Chino. I'm co-inventor of Taiga Smart Systems, and we have integrated sensors that I guess you could say we are creating self-inventorying facilities utilizing AI to make them powerhouses. My question for you is, because the sensors have got to be able to process the data, as Gen AI gets more and more sophisticated, how does that affect the hardware that's being used to even receive the data? Do you see what I'm saying? They really need to stay orchestrated with one another. Yeah.
The use of generative AI is going to change the dynamics of what's needed in the hardware dramatically. But you got to work with what's out there to begin with. And so any system, you're going to take what's out there. Like we work in that case in the Middle East, we have old cameras, new cameras. Some of the cameras have AI. You got to be able to integrate all of that stuff. But there's going to be a feedback loop here, because once you see what generative AI can do from that data, you're going to say, hey, I wish I also had that data to feed it. And not just data from sensors, but also services are going to change, because weather has so many services that are good. You use them, but you may require new ones. And so we're going to see a feedback dynamic as this technology advances, unlike ever before. And no one company is going to do it. It's going to be the whole ecosystem, the whole environment. But admittedly, it's a challenge. But here too, walk before you run. Take what you have, whatever sensors, integrate them, and then move on.
Now, Tony said sometimes you have to run before you walk, so we might be in that. I don't know.
I like that quote.
So
yes.
Here's a question that I want to pose to the audience while Marty's up here. We talked about this. There's going to be different roles in this process. And different folks in this room have different roles in business and where you are. How many of you all make sensors? Raise your hands high. How many of you all integrate things? Raise your hands high. How many of you all came for a different meeting? Okay. How many of you all? For lunch, that's right. That's why we started at 1. So how many of you all do something with the outcomes? All right. How many of you all are trying to figure out how this all comes together? Everybody ought to have their hands up.
Yeah.
The reason I say this is, in the discussion, Vantech becomes the transport mechanism between the sensors and the outcome. Any kinds of inputs, any kinds of outputs. That's not what the platform decides. Correct, Marty? The platform is just providing that conduit to be able to do it. So as you're sitting here, you think of traffic lights, you think of emergency response. I'm from New Orleans. I don't know why flooding appealed to me. But when you're thinking of those things, which role do you play in this? And do you need to partner with other people that have different roles to make this successful? And the question that you asked about sensors being outdated, Marty, you might talk about they may not be a candidate for this if they have outdated sensors and their infrastructure is too high of a cost. That's probably not the target for this. But people that are reviewing it, kind of how do you see this coming together? What are kind of the 3 or 4 pieces that would need to be seen for folks to take action on this?
Well, regarding sensors, any sensors out there should be, assuming they have an API, and it's hard to imagine any today that don't, should be accessible. And it may have limited data. So when you're dealing with sensor fusion, combining them, some provide this data, some provide this data, and your analysis of it is going to vary. The other question is, what's going to happen in the industry is sensors are going to proliferate like crazy. So those of you who raised your hand that, how many of you create sensors or integrate sensors, you've got some big jobs ahead of you, because it is going to be needed like never before, because it's a feedback loop. These generative AI systems are going to analyze what's coming out of the sensors, and it's going to require more sensors. In terms of, there is no greenfield type applications here. We don't see them. There's always some amount of information, some amount of sensors, some amount of databases that you've got to combine. You've got to live with what you have and then build on top of it and maybe evolve it with time. But just trying to change what you have, it's just not in the cards. It's too difficult.
Questions? Yes, ma'am, right here. If you have a loud voice, just stand up and shout. If not, I'm on my way. Oh, hold on. Here we go. You have one there, too.
All right, Christy Wilkerson. So I'm here with Jacobs Solutions, Inc. And so Marty, I've been going through everything that your company's done and the product and the platform, and it is incredibly visionary. And so one of the things I love is Simon Sinek, and he talks about start with why. So what I would love to hear from you is what took your company on this journey to begin with? Why did you guys go down this path to create something so unbelievable that I know is going to change the world?
There was okay, I'll have to tell you this story. So there was a trip I was on about now more than 10 years ago, and it was a Russian nuclear-powered icebreaker, when we were friendly, to the North Pole. And we had all of these environmentalists, climatologists, and people concerned about the environment, and they were talking, whether you believe in climate change or not, they were talking about the impact of what's happening in the world. And I realized we need to monitor this stuff. Software can do that. We need to see what's happening and get people to safe places when there's flooding somewhere, et cetera. So that was the first thing. My time's up.
It's a sense.
Any other questions? Sorry, let me continue. The second thing was, I spoke to Paul Butterworth, co-founder, who was actually, we hadn't spoken for 5 years. He had the exact same idea. He said, we need to be able to build systems, whether it be for safety, for defense, for disaster management, to help address the world. We had this background. We were the first company at Forte Software, a previous company, that made the internet work for mission-critical applications. In fact, I couldn't get funding back in the mid-90s because VCs were saying to me, this internet thing is going to be a flash in the pan. That's a real quote. The other one said, home banking on the internet? No way, you can't put real data on the internet. So we were foresighted. And I think the same thing when Paul and I spoke here, we were saying, we're about to operate the world totally differently, and what does it take? And there were two major criteria before we even chose how the technology would work. One criteria was you have to make it agile, because everything is growing, sensors and logic, and it's going to be everywhere. It's the cloud, it's the edge. So agility, how do we make it simple? And the second criteria, how do we make it reliable? Same thing we did at Forte. How do you build these systems that don't crash or have backup? How do you assure a message when sent is guaranteed to get to where it's going? And so we took those approaches from prior history. We said that the world is going to be automated to a large degree. and let's build a system to do it. Now, having said all that, I do want to add, I alluded to it before, there was one big factor of luck that came into being. So we saw the Tony Stark movie, and we were basically saying, okay, we have to have huge man-machine collaboration and make it easy for the man to control it or the machine to control it or just blah, blah, blah. So we built collaboration to the system. But it wasn't general enough. It was very specific. It was deterministic as to what you do, like a workflow. With generative AI, everything becomes a whole new world. You're getting all of this information you can base your decisions on, potentially. And so that grew incredibly. So it was a combination of having done kind of this stuff before. Some people kid around that this is release 2 of the software we've done before, and seeing the problems that were occurring. Now, having said all of that, we were still early to market, but I'd rather be early to market than late. And when generative AI took over or came in, it's our usage is growing like crazy. POCs are tripled. Our pipeline it's I'll take the right place at the right time, anytime.
Thanks, Marty. Thank you very much, sir. All right.
Thanks.